on how to create a S vector or the S variable in Homer2 or for Homer2. If you go to the website, it's homer-fnearest.org. Under the frequently asked questions, the FAQ, you actually find links to all the conversion scripts. This is anything for a Hitachi machine, a Nirex machine, a Shimadzu, and an Artenis. The Artenis you would have to directly contact Artenis for, but the rest of them have been written by various researchers around utilizing these systems. Most of these conversion scripts will actually incorporate the S vector development within it. But I did note that let's see, the Nirex script itself will actually incorporate the exact vector that you need, the S matrix that you need. Shimatsu will actually have the time points, but you will have to designate which condition it is later on in Homer 2. And Hitachi actually will save it in the auxiliary variable, the AUX variable. I believe I'm not too familiar with the Hitachi system, or at least working with it, but you may have to just simply put S equals AUX in your MATLAB script, but I'm not exactly sure about that. As far as actually creating the S script from scratch, so let's say you use a different system, maybe perhaps a in-house built system, or you have a system, or in one of the conversion scripts you just want to include yourself. It's as simple as very basic MATLAB script. Here I actually have my D, or my data variable, in my workspace. Uh, in Nirex output format, which I'm more familiar with, you do have things like a .evt variable, which just basically looks something like this. You have your frame point followed by your binary code for whatever condition you're actually using. You also could look into the header variable, the .hdr variable, which is used in the Rob Cooper script. But aside from that, if you know how many conditions you have, which if you're performing an experiment, likely you would, here I actually designated an EVTS variable, and I say here in this case I have 3 different conditions. I then create my I create my S matrix just as zeros, so I create, and I can go line by line here. I create the EVTS file as equal to 3, so now it's in my workspace. I then create my S matrix as a matrix of zeros, and I'm going to do it the size of my D variable, which is my data. That means basically that I'm going to have all the rows of my data. It'll have every single time point that I had within the experiment. The columns, though, will be the number of event points, which I just defined. And you'll notice here, now I've created it. On the right, you see it. Now I have 3 columns with a whole bunch of rows of all zeros. Then I actually have to know kind of a priori which events were at which time point. So you can do that a number of ways. Hopefully you were recording it during the experiment. You know when these onsets were. Likely you would know also which condition was occurring at one time. Um, so here I'm going to designate the variable evts1. That's going to be my condition 1. I put that as just frame. It's going to be frames, not seconds. So frame 5, frame 10, frame 15, and frame 20. So now what you'll see over here is frame 5 will now become, actually, excuse me, I have to now designate this. So I've created essentially these points, or these marker points, and now I will designate it, and you see frame 5, frame 10, frame 15, and frame 20 have now become 1s in column 1. That would be my condition 1. Then I would do the same for my conditions number 2. So I'd create, again, let's see, in this case I call it events 2 at 25, 30, 35, and 40. Go ahead and create it. Now it's in my workspace. And I'm going to do the same where I say basically the second column at all rows of events 2 will now be 1. And you'll see down here now I have 25, 30, 35, etc. So here finally I'm going to do the final step for events 3, which again I designate as 45, 50, 55, and 60. I'm going to go ahead and run that. And I'm going to now designate all of column 3 at those rows to be equal to 1. And now, as I scroll down here, you will see at 45 I have a 1 in column 3. At 50 I have a 1 in column 3 again, 55, 60, etc. So this is just very basic as to how you could potentially manually input an S vector. You would need obviously the time points that you had conditions occur, and you would need to know what condition occurred at that time point. So when you're running your experiment, be sure that you're recording those exact numbers. Aside from that, if you actually dig into, like here I have the Nerex conversion script, you'll see find event markers and build S vector. Rob Cooper just dug into the header file, which is an output by Nerex, looked for the event markers, and ran this script. For Shimadzu, it became saved, I believe, under the, it was saved here out of the data as column 3, I believe it was, but it wasn't registered as noted in the comments. Here, Shimadzu text file does not provide the condition-specific stimulus, so you would actually have to then go into Homer later on and actually indicate which stimulus was which condition. For Hitachi, it's going to be saved. Here it mentions the stimulus markers are stored in the AUX variable. So there is the creation of the S matrix. It seems to me, and again, I don't have any Shimadzu data to work with, but it seems to me it could be as simple as saying S equals AUX, or to show you something like that would give you the output that you need. I'm not certain about that, but worst case, you can create your own S vector as shown earlier. So that's just a very basic run through of how to create the S vector. I noticed that it was mentioned a few times in the forum as to what this was and how to create it, so I hope this does help. Next up will be a simple creation of the SD struct, and I hope this makes it easier and easier to run through Homer. Thank you guys.